Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to talk about how we can write a Kubernetes operator, or in other words, how we can write a Kubernetes custom controller for custom resources or for the resources that are not already there on the Kubernetes cluster. So the operator that we are going to write is going to be called Kluster, Kluster, and this operator is going to provision Kubernetes clusters dynamically on DigitalOcean. So when we create a custom resource that we are going to look into, a Kubernetes cluster should be provisioned on DigitalOcean, and as soon as we delete that custom resource, Kubernetes cluster should be deleted from DigitalOcean cloud provider. So this is what our operator is going to do. Now the prerequisite for this particular video or session is going to be a playlist that I have created about basics of ClientGo. So I would highly recommend checking that out. And there is another playlist that is about writing Kubernetes custom controllers. So if you go through that playlist as well, I think the things that I'm going to talk about now are going to make much more sense. So let's first try to understand what exactly we are trying to build. So let's say we have this Kubernetes cluster up and running, and in this particular Kubernetes cluster we want to deploy an operator. So for example, let's say this is our operator that we are talking about, and once this operator is deployed on Kubernetes cluster, if I try to create a new CR that we are going to look into, if I create a new CR, this operator is going to look for this CR, and as soon as this CR is created, our operator is going to create a Kubernetes cluster on DigitalOcean. So this is what our operator that we are going to write is this is what this operator is going to do. Now as soon as we delete this CR that we have created, this cluster that was created on DigitalOcean should automatically be deleted as well. So this is what we are going to look into. Now, first of all, if we have to create a DigitalOcean cluster, let's go ahead and try to look into all the fields that are required when we try to create a Kubernetes cluster. So let me quickly open the documentation, and here we have the documentation or API reference for DigitalOcean cloud provider. And if we see here, to create a new Kubernetes cluster, we need name of the cluster, region of the cluster, and we also need version, and then we need node pools. So these are four required things to get a Kubernetes cluster deployed on a DigitalOcean cloud provider. So somehow we will have to get these fields from somewhere, and this is where custom resources come into picture. So if you know basics of Kubernetes, we don't have any Kubernetes native resource where we can specify all these fields. So for example, this is the use case where we will have to create a custom resource, because to specify these fields we should have a resource where we can specify all these fields, and this is the reason we are going to create a custom resource, obviously with the help of CRDs. And then once we have CRDs and CRs in place, this operator that we talked about, this operator is going to listen on creation and deletion of those CRs, and as soon as they are created or deleted, this operator is going to do certain things. Now, if you are not very sure about what exactly CRs and CRDs are, I already have a video about that as well. So maybe I'll link that in description, and you should check that out as well. Now that we know what we are going to build and what are all the fields that are required to build that operator, let's go ahead and try to look into how do we actually specify, how do we actually tell Kubernetes that we are going to support a new type, let's say, or new custom resource. So if we talk about this custom resource that we are talking about in this diagram as well, this custom resource, or using this custom resource, we should be able to specify all these fields. So name, reason, version, and node pools. And when we try to create an operator, or when we try to, let's say, register a new object to Kubernetes, we have to create our project in a certain way, or in a specific format that we are going to look into in a bit. Now, if you look into my, as I said, basics of client Go playlist, you would actually get to understand what are all the things, what are all the requirements that a particular Go type or Go struct should have, so that it can be called a Kubernetes object, and that is going to be very useful in this particular video. So now that we have a very clear basic understanding setup, let's just go ahead and try to create the Go project. So we are obviously at this particular location. Let me just go ahead and print Go environment once, so that you can match if this is how your Go environment is set up or not. So we are inside Go path, because Go path is home Vivek Go, and we are in home Vivek Go, source GitHub, and my GitHub handle. So we are in Go path. Now let's go ahead and try to create a directory named Kluster, because this is the name of the operator that we are going to create. So cd into Kluster, and then let's open it in a text editor. Now we are inside that project. Let's go ahead and try to initialize a Go project using Go mod. So Go mod init github.com/Vivek Singh /Kluster, and as soon as we run this command, we should get a go.mod file created in the root of the directory. Okay. Now let's go ahead and try to create. So we have to register this type that we are going to get as a CR, as I said when I explained this. So to do that, let's create the directory structure or project structure. Now before doing that, we will also have to specify. So we know that every Kubernetes resource or every Kubernetes object is part of a group and version. So for example, if you talk about deployments are part of apps group and v1 API version. Similarly, the type that we are going to introduce, that type should also reside in a group and version. So let's say the type that we are going to introduce is Kluster, and it should be in Vivek Singh .dev or Vivek Singh dev group, and version would be v1 alpha 1. So let's also create a very simple readme.md, and I'm just going to note the things down here. So we want to introduce a type named Kluster, and this is the type that we are going to create using the CR that we talked about. So this is the type, and this should be in Vivek Singh .dev group, and version is going to be v1 alpha 1. So this is our requirement, and this is what we are going to do as the very first step of this particular project. So let's go ahead and try to create some directory. So package APIs, and then for APIs we specify which particular group our type is going to be part of. So this is going to be part of viveksingh.dev, and then we have to specify API version. So v1 alpha 1. So I hope this makes sense. So package APIs and then group, which particular group our type is going to be part of, and then version. Now that we have this directory structure, let's go ahead and actually specify how our type is going to look like. So we have looked into the documentation that this is how these are all the fields that are required to get a Kubernetes cluster created. So let's go ahead and create a new file named types.go. Now these things are, I would say, very standard. For example, name of this file must be types.go and the directory structure must be like this. So I think you should keep this particular thing in mind. Now that we have types.go, here we will have to specify how our type is going to look like, how our custom type is going to look like. So this is obviously going to be package v1 alpha 1, and the type that we are going to introduce is cluster. And yeah, so this is the type that we are going to introduce, and this type is obviously going to have specification. So every Kubernetes object or resource has basically three fields or three main parts. So those are, I would say, type meta, object meta, and spec. So type meta specifies which particular type of resource it is. Object meta specifies other details about object, for example, name, namespace, etc. And then spec actually specifies the specification, the configuration, or the details about that particular object. So this particular object is also going to have all those things. So we know that type meta and object meta can already be used from API machinery meta v1. So meta v1 API machinery, and let's just import that. And we are going to call it meta v1 and meta v1 dot type meta. So apart from type meta, we would also need object meta, and then we would need spec of this struct or type that we are going to introduce. So let's call it spec, and the type is going to be cluster spec, and we will also have to specify cluster spec, obviously. So let's just go ahead and try to maybe download the binaries. So we are also going to create main.go, and inside main.go we are just setting up the project. Now once this project is set up, maybe I'll try to explain things again, and things would make much more sense. So func main, and let's, for the sake of building the project, I'm just going to import this package and use this cluster struct. So import and github.com/viveksingh cluster package APIs and okay. Alright, so cluster spec is not defined. So let's just go ahead and try to define cluster spec as well. So type cluster spec is going to be struct, and this is the place where we specify what are all the fields that are required when the operator is run, or what are all the fields that should be provided as input to your operator. So let's just go ahead and try to fill in all the things that we saw in here. So first of all, we are going to need name, reason, and version. So name is going to be a string, reason is going to be a string, and version is also going to be string. So we can also see the types here. So string, 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 and then we see node pools, and node pools are object of node pool. So we are going to say node pools, and this is slice of node pool. And let's define node pool as well. So type node pool struct, and inside node pool, what we can have is we can have size, name, and count. So these are, if you see here, node pools is a slice obviously, and fields of that slice of type node pool, and fields of that node pool are size, name, and count. So we are going to say size is a string, name, and count. So name is also string, and count is going to be integer. Okay, so now we actually have a type, but the very important thing that we have to understand is we just have created a go struct. This doesn't necessarily mean that this particular type or this particular struct is a Kubernetes object. So to do that, what we have to do is we have to first of all register this particular Kubernetes object using schemes or in schemes, and I think that is the most important thing of this particular video, and we can do that using another special file, I would say, that is called register.go. So new file, and we are going to call it register.go. So we know the significance of types.go. We specify all of our types there, and then using register.go we are going to register this particular type in Kubernetes scheme, so that Kubernetes would know that there is a type named cluster that I have to respond to. So this is what we are going to do using register.go. Now to actually look into the format, or how do we register a specific object, we are going to refer another project. So alright, so this is from upstream git remote -v. If you see here, Kubernetes and code generator, and this is what we are going to refer to actually look into how we can register a specific resource. So if you see here, they are registering a type named test type, and this is what we have to do as well. We have to register a type called cluster. So let's just go ahead and try to refer this, and we would be good. So first of all, package v1 alpha 1, and inside package v1 alpha 1 we have to specify this variable scheme group version that is used by the code that we are going to generate in a bit. So whenever we register a particular resource, as I said, we will have to specify which particular group and version that particular resource is part of, and that can be done using this particular variable. So let's do that, where scheme group version equals to, this is going to be schema dot group version. So let's import this. And schema dot group version, and we can specify group to be, we know that the group is vivek.dev and version is v1 alpha 1. Okay, so now that we have specified group version, what we want to do is, as soon as this package is loaded, we want to register this particular type. So to do that, what we can do is we can leverage func init, and we know that init function gets called as soon as the module or the package is loaded. And inside this init, what we are going to do is we are going to call a function that is going to register our type to the scheme. So if you see here, we are going to use scheme builder and scheme builder is going to be runtime dot scheme builder, and we are going to call scheme builder dot register, and scheme builder dot register expects a function. So if you see here, if you look at the signature of register, it expects functions. So, and those functions are going to register the type to the scheme. So let's call our function add known types, and we will have to define that function. So func add known types, and this particular function should be of a specific signature. So error, and it also expects runtime dot scheme. So runtime dot scheme. I think we should be good now. Okay, so if I try to explain it again, we have created types.go, and we have to register this type to the scheme using register.go. And to do that, what we have created is we have created scheme builder from API machinery runtime, and then we are calling scheme builder.register with a function that is actually going to register the type into the scheme, and that we are going to do in just a bit. I'm also referring to the code that I have already written, the same code. So yeah, that is what I'm looking at. So we are going to say scheme dot add known types, and when we call add known types, if you see here, we have to specify group version and then actual type. So the group version, we have already specified group version to be scheme group version here, because we know, or we want our type to be part of this group and this version. So we are going to say scheme group version, and then type is going to be cluster. Okay, I hope this makes sense. So we are not actually doing a lot of things here. We are just using scheme builder to register a particular type to the scheme using scheme.addNownTypes. And we also specify which particular type we want to register to our Kubernetes cluster in very simple terms. Now we are having this issue here because as you should know, if you have watched the basics of client Go, if a particular Go struct needs to be called as Kubernetes resource, in that case it should implement some methods, it should implement some behaviors, and those behaviors are we should be able to deep copy that object, and we should be able to set and get group version for that particular type. And that is what we are that is what's failing here. So it says deep copy object method is not available on this particular resource. So this is one thing because of which we are actually going to use code generator to generate some scaffolding around this type, etc. So I hope this makes sense. Now what we have to do is, for example, if you remember, when we run kubectl get pod and then we specify a pod name, we get a pod, but when we say kubectl get pods, we get a pod list. So we will also have to specify another type here named cluster list. So type cluster list is going to be struct, and it obviously also going to have meta v1 dot type meta, and then meta v1 dot object meta, and then it is also going to have a field items, and it is going to be slice of cluster. And we will also have to register this particular resource as Kubernetes object. So let's just go ahead and try to do that as well. So ampersand cluster list, and here we go. So now that we have registered these two objects, the other thing that we have to do is we have to use meta v1 dot add to group version, and here we specify scheme, and we also specify group version. So scheme group version. I think we are in a good shape now. Now what we should go ahead and try to do is, now we should discuss why do we exactly want code generators. So as I said here, to register a particular struct to a Kubernetes cluster, or to treat a particular Go struct as a Kubernetes resource or object, what that particular object should implement some behavior. That object should be deep copied, or that object should implement behaviors using which we can get and set group version. So these are some of the things that I can remember. So two things about setting and getting group version is already implemented when we used these two types inside, or when we embed these two types inside cluster, similarly for cluster list, but we still don't have deep copy object. So that is the reason we have to generate deep copy object for these resources. So deep copy object is one thing. Another thing is, let's talk about ClientSet. So if you looked into my videos where we wrote a Kubernetes custom controller, we obviously used ClientSet to get, list, delete, update specific Kubernetes native resource. And the client set that we used, that client set will not be available for the custom resource that we are going to register. So the client set is not going to be available for this particular type that we are talking about here, so for example cluster, so we will have to generate a client set as well. So deep copy object, client set, and if you remember again the same playlist where we wrote Kubernetes custom controller, we also use informers and listers. So informers are used to let operator know that a particular resource was created and things like that, and then lister is also used to get the resource from informers cache. So those are two other codes that we need to generate. So if we go to readme again, we need to generate these things. So first deep copy objects, second we need to generate client set, and we also need to generate informers, and we need to generate lister as well. And to generate all of these things, we are going to use another I would say project that Kubernetes maintainers maintain, that we very quickly looked into, that is code generator. So this is what we are going to use to generate this entire code. Now, before actually generating the code, what we are going to look into is, we are going to look into another source file called doc.go. So let's just go ahead and try to create doc.go as well. We know the significance of types.go, we know the significance of register.go. Now what we have to do is, we have to talk about doc.go. So again, it is going to be obviously package v1 alpha 1, and doc.go basically is used to specify the global tags for your API. So and we are going to again talk about tags in a bit, but for now you can just assume that, or you can just think that this is the file where you can specify tags for your v1 alpha 1 API. Now if we talk about tags are I would say the way to control the behavior of your code generator. So as I said, we are going to use code generator to generate all these things. So obviously code generator expects some arguments and flags, but beyond that you can also use tags to control the behavior of code generator. And so this is why we use tags. And there are two types of tags, global tags and local tags. So global tags can be specified in doc.go, and I would say that is the significance of this doc.go file. So yeah, if I try to summarize it again, we specify global tags in doc.go, and tags are ways using which we can control the behavior of code generator. Now, how do we specify tags? Let's just go ahead and try to look into that. So I'm just going to copy a block of code here. So if you see here, it simply says that these are all the tags, and obviously global tags, because we are specifying that in doc.go. It simply says that, so this is the format of a tag, so plus something equals to something. So here we are specifying deep copy gen equals to package. It simply means that deep copy methods should be generated for every type that is specified at the package level. So I hope that makes sense, and this is how we specify tags, and this is how we specify tags. Now that we have specified tags in doc.go, if we have to specify some tags for local source files, we can do that using another way, that is specifying tag for types specifically. So we want to generate, if you see here, if we look into this particular tag, we obviously want to generate a client set for this particular type, and we are specifying this here because we have not specified that in global tags. And even though we want to generate deep copy method for this type, we are not specifying deep copy here because we have specified that in global tags. So this is what is the significance of tags tags, local tags, and global tags. All right. So now that we have specified almost everything, I think, let's just go ahead and try to generate the scaffolding code now. So as I said, if we these are all the things that are generated by code generator. But if you want to generate just one thing, you can do that using code generator flags as well, or you can use tags as well. But we want to generate every one of these. That is the reason I'm going to use a specific command to do that. So let's just go ahead and try to do this. So this is how our directory structure looks now, and as soon as we run the code generator, we should have a deep copy function for the types in v1 alpha 1, and we should get all the lister, informers, and client set generated inside package and client. So let me quickly go ahead and copy the command that I have written. And the basic requirement is you would have to download code generator, and you can very easily do that by going to Kubernetes code generator, and here we go. And you would obviously have steps on how to install it. You can just go get, and as soon as you go get, this particular code generator module would be available in your go path, like I have. So my go path is this, and then go source K8S.io code generator. This is where I have downloaded, or let's say installed, code generator. And what we want to do is, if we, for example, look at this particular command, this is where a lot of folks face a lot of issues. So this is the command that I'm going to emphasize on a lot. So obviously we have inside code generator, we have generate groups.sh that we just looked into. So here we should have generate groups.sh. So this is the .sh file that we are invoking here, and all simply means that we want to generate code for all these things. So deep copy objects, client sets, informers, listers, all these things would be generated. So this is why we are specifying all, and then we are specifying the module where we have to generate all this client code. So a lot of times people get confused about what should be the correct value of this particular flag. So this should be your module name. So we have initialized our go mod with github.com, Vivek Singh's EasyITS cluster, and then package client. And then we also have to specify where our types are. So our types are obviously at cluster package APIs, and then we have to specify group and version, and then we just have to specify so when these code bases are going to be, source code is going to be generated, there should be a licensing information, and that is the information that is here in the boilerplate.go.txt. So let's just go ahead and try to run this and see if things are working as expected. So if we see here, this is how the package structure looks like right now. I'm going to print go environment once again, and now let's just go ahead and try to run the code generator. And if you see here, it is generating deep copy functions, and once deep copy functions are generated, it is going to generate the client set, and then informers, and then listers, and this is where all these things are being generated. So this is going to take just a second. So now if I run the same command again, if you see here, we have client created, we also have a DeepCopy.go file, and we have everything. So inside client we have client set, we have informers, and we have listers as well. And this is what we needed. So if we refresh this again, here we go, everything has been generated now. And if we go to register.go, this error has also been removed because now deep copy functions have been generated. So now that we have generated the code, let's go ahead and from main.go we should try to, let's say, list all the clusters that are, or all the cluster resources that are created on our current Kubernetes cluster. So to do that, I'm going to copy some of the code base that we have already discussed about. So for example, I'm going to I'm going to copy this code. So this is just going to this might take a time. I'm sorry about that. So let me quickly explain what we are doing here. So we are just going to figure out where the kubeconfig file is, and once we have figured out kubeconfig file, we are creating we are parsing that kubeconfig file using client cmd and build config from flags. Now, once we have config, what we can do is we can create the client set, if you remember, because we have generated the client set using the code generator. So to do that, what we have to do is we have to include or import this particular package. So client set and versioned. So let's import that. So github.com/viveksingh.dev/ cluster package client, and then inside client we have client set. If you see here, client set, and we have version, and let's call it client. And we are going to, so if we refer to this particular code base again, if you see here, we are calling kubernetes dot new for config, to create Kubernetes client. Similarly, we can call new for config in this particular package that we have created. So client dot new for config, and if we specify config here, we should get client set :error, and if error is not equals to nil, in that case, let's say we just want to log that. So log.printf getting client set, and this is the error. So error. And just to make sure that we got client set successfully, let's just print that. So print ln and then client set. Okay, let's just go ahead and try to build it now. I think things may fail, but let's see. So it actually downloads the dependencies and then builds them. So that is the reason it might take some time. But if I try to explain it again, when we try to get client set for Kubernetes native resources, we use kubernetes.new for config. But when we try to get client set for custom resources, custom types that we are going to introduce, in that case we have to import the client set. If you see here, this is the client set that we generated, and that is the reason we have this imported this particular module here. Okay, so it says I know about this problem, and that is the reason I think we are going to solve that quickly. So if you see here, we have API of version 21.3, API machinery with version 21.3, but for client Go, we are using this particular version. So let's go ahead and try to install client Go with this particular version itself. So we are going to do that using go get, and I think this is the command. So, and the version that we want to download is, here we go. It simply means that I want to use this particular version, and if you see here, this has been updated. And if I go ahead and run go build again, okay, so now if you see here, register.go also expects a variable named add to scheme. So that is what we are going to, that is, I think that is what we forgot, and that is what we are going to specify now. So if we go to register.go, where we have specified scheme builder, we should also specify add to scheme. So add to scheme, and the value is going to be scheme builder dot add to scheme. So scheme builder dot add to scheme. Alright, if I go and try to build this again, let's see what happens. Okay, so now things are working, I would say, as expected. We have a binary created, and if I run this, so, and we are also getting client set. So if you go to the main.go, we have printed client set, and it is not printing nil. It simply means that we are getting client set. Now I think now the format that you're going to see should be very familiar with you. So client set, and if I hit enter, if I hit dot, I should be able to query using group, and the group that we have specified is Vivek Singh dev. So dot, if you see here, Vivek Singh v1 alpha 1, and then dot clusters, and we have to specify namespace here. Dot, if I let's say get or list context dot background, and then we have to specify meta v1 dot list options. Okay, and it gets us clusters colon error. If error is not equals to nil, we just want to, let's say, log that as of now. But if you are running this on production, you might want to do something else. So getting or listing clusters, the error is this, and error dot error, and let's range over, or let's return length of clusters. So fmt dot printf length of clusters is %d and length of clusters dot items, because we know that list is going to get us items or list of all the clusters. So let's just go ahead and try to build and run this again. So go build, and now we are going to run this. So if you say here, it says okay, the server could not find the requested resource. The other thing I think we missed is, if we go to register.go, we register cluster list. I think we will also have to register spec. Alright, I'm going to pause the video for a second and I would try to resolve this, and then I would get back. Okay, so I spent some time looking into this, and I think while discussing all these things, we forgot very important point. So even though we are registering these types to Kubernetes cluster, Kubernetes is not going to know if there is a type with this particular, if server has to respond to this particular type, until and unless we create the CRD, because CRDs are the ways using which we specify, we register new types to a Kubernetes cluster. So I would say registering this type and creating CRDs should go parallelly or hand in hand to actually achieve this. So now that we have main.go ready as expected, let's just go ahead and generate the CRDs. Now to generate CRD for meanwhile, what I have done is I have also added these tags to the fields, just to make sure that we are not facing issues because of this. So this is all I have done. I have just added these JSON tags in our types.go. Now what we have to do is we can use another utility called controller gen. So I'm going to I'm going to specify all these things in the description as well, but this is how you can use controller gen to generate the CRD for your type. Because if your type is very simple, in that case you can generate the CRD manually, but if your type is not so simple, in that case you will have to, or you should use any tool to generate the CRDs. So let's just go ahead and try to do that. So I'm just going to copy the command over. So this is the command that can be used to generate the CRDs. So it just says generate CRDs, controller gen is the tool. This is the path where our APIs are, or where our types are, and then we are setting trivial versions to true, and then we are specifying. So CRDs are or were present in v1 beta 1 as well as v1. From 1.22 they are not going to be available, but they were present on v1 beta 1 and v1. So we are explicitly saying that we want CRDs to be generated in API version v1, and we specify out to be generated in manifests. So let's just go ahead and hit enter, and as soon as we hit enter, we get a directory created here, manifests, and inside manifests we have if you see here, CRD has been generated. So custom resource definition group is obviously going to be vivek.dev, kind is cluster, and this is the spec, etc. So now that we have CRD generated, let's go ahead and try to create the CRD. So kubectl create -f manifests, and then we are going to create this CRD. Now, if we list all the CRDs, we should get this CRD, that this CRD has been created. And let's run go build again and clusters. Here we go. Now we are not getting that error, and we are obviously seeing length of clusters is 0 because we don't have any cluster resource created in this Kubernetes cluster. Now let's just go ahead and try to create a very simple CR, cluster CR. So let's go to main.go, comment out this one, and we are going to create a file named cluster1.yaml, and inside cluster1.yaml we have to follow the same pattern using which we specify any Kubernetes resource. So API version, kind, and spec. Now API version, we know that we have introduced the type in group viveksingh.dev. So viveksingh.dev/version, and version is v1 alpha 1, and kind is going to be cluster, and metadata, so name is going to be, let's call it cluster 0, and inside spec what we have to specify is we have to refer to CRD. So inside spec we can specify name, node pools, reason, and version. So for now let's just specify name to be let's say cluster 0. We can read the name from resource itself, so we can discuss about that later. And reason is going to be, let's say AP South 1, and version is going to be, let's say 1234. This is going to fail, but I'm just trying to show you something. So create -f manifests, and then cluster1.yaml. This is going to fail because the validation that we have specified in CRD. So this is the CRD, and we have specified that version should be string, but in CR we are specifying version as int. So let's make this string, and if I create this again, if you see here, cluster has been created. So if I say kubectl get clusters, we get this cluster, and this is exactly the same thing that we are going to get when we run cluster. So if you see here, length of cluster is 1, and we can change this to print name as well. Cluster is 1 and name is %s, comma, clusters dot items 0 dot name. So go build, and if we run this again, we should see cluster 1. So, and here we go. So yeah, I mean, this is what I wanted to show in this particular video. In the next in the coming videos, we are actually going to use the informers and listers that we have generated to write an operator that is going to get all these values that we specify in CR, and then going to actually create or provision a Kubernetes cluster on DigitalOcean. So yeah, if I try to maybe summarize the entire thing once again. So when you create a CR and CRD, so for example, CR and CRDs are the ways using which we specify that this particular resource is also supported by Kubernetes cluster. And once we have done that, we will have to write a piece of code that should do something when a particular CR was created. So in our case, we have registered a type, and to make sure that that type is understandable by Kubernetes cluster, what we have done is we have used register.go here to specify that this particular type should be recognizable by Kubernetes cluster. Now, this particular type should be treated as Kubernetes cluster. To achieve that, we have to implement certain behaviors for this type. Those behaviors are already implemented by, some of those behaviors are implemented by meta v1 type 1, meta v1 object meta, but deep copy behavior, deep copy functions are not implemented. To do that, we used code generator, and once we have used code generator, we generated all these things. And once all these things have been generated, we used controllers in to generate the CRD. Once CRD was generated, we created the CRD, and from main.go, we obviously used the client set that was generated to get the client set, and then we actually got the cluster resources. So I hope this makes sense. I'm obviously going to push this entire thing on my GitHub repo, and I would push the README as it is as of now, but we are obviously going to modify this in incoming videos. So yeah, if you think this is going to be helpful for your colleagues, classmates, share it with them. Thank you so much for watching, and I'll see you in the next one. Thank you so much.